Hi, good evening, friends. I'm Gaurav Gupta and I welcome once again all of you to the YouTube channel of BYJU'S Exam Prep. Now, BYJU'S Exam Prep is the most comprehensive app for all the entrance examinations, including CAT and other MBA entrance examinations. Now, friends, here at BYJU'S, we offer a lot of products which will help you in going for an end-to-end preparation for all your entrance examinations so that you can achieve all your dreams. Now, friends, like I said, I once again welcome you. So basically, you all must be attending all the sessions that I have been conducting in this series of Algebra. Okay, so if you have attended the previous sessions, the last few sessions in which I have given you a lot of gyan on functions. So we have studied basic type of functions, uh, like the types went from discussing about the classification of functions, which is based on correspondence of functions. Then we have seen some particular types of functions, including log functions, modulus functions, quadratic functions, and so on. Okay. Now, in my previous lecture, I have told all of you that I'll be starting with a series in which I will be discussing all the plotting of graphs of different types of functions. So here I am in front of all of you. So starting today, for the next 3 or 4 sessions, we will be discussing each and everything related to the plotting of graphs of different types of functions. So there are various rules pertaining to plotting of functions. Okay, so we'll be talking about all these rules one by one. All right. Now, in this particular session, let us first of all quickly define the agenda. Okay, so I'll be starting with the graphs of linear expressions. So I'll be giving you very basic insight about what are linear expressions and how do we plot their graphs. Now, this is a very elementary thing. Then from linear expressions, we'll shift our focus to the graphs of quadratic expressions. Okay, so once again, I'll be starting with the basic expressions in quadratic. Okay, and then we'll be gradually increasing the level. All right, now uh, after that, we will be discussing a very general technique of plotting different types of graphs. Now, this particular technique will not only help you in understanding different variations of quadratic expressions or cubic expressions, but it will also teach you a basic fundamental of plotting the graphs. Now, this particular concept is called shifting of graphs. All right. So this will be a particular agenda for all of us in today's session. Hi, Siddharth. How are you? Good evening. Okay. So, friends, let us start with today's session. Okay. So, first thing is the graphs of linear expressions. Now, as all of you know, if I look at a general form of a linear expression in two variables, then it will be of the form ax plus by plus c equal to 0. Now here x and y are variables and a, b and c are constants. Okay. Now if I look at the graph of any linear expression, then it has to be a straight line. It will always be a straight line. So you are given linear equation in two variables. The graph will always be a straight line. All right. Now, when we are plotting the graph of a linear function, since we know that it will be a straight line, so to plot a straight line, we just require 2 points from which this line is passing. Okay, so if on the graph, if on the xy plane, we have located 2 points from which this straight line is passing, then joining these 2 points will draw a straight line that will be the graph of this linear function. Okay. Now to obtain these 2 points, there are a lot of methods. Okay. Now what I generally do is I calculate the x-intercept and the y-intercept of this equation. Okay. So x-intercept and y-intercept are the 2 points on which the line will intersect x-axis and line will intersect y-axis. Okay. So let us first of all understand how to obtain x and y intercept for a given equation of line. Okay, so consider this general equation ax plus by plus c. Now if I'm talking about x-intercept, then x-intercept is the point at which the line will intersect x-axis. So the point at which the line will intersect x-axis, at that point the value of y will be equal to 0. So I'll substitute y as 0 and will obtain the value of x. So the value of x in terms of a, b and c, it will become minus c upon a. All right. So it will become minus c upon a. All right. Now, simultaneously, if I'm talking about y-intercept, which is the point at which the line will intersect y-axis. So here, the value of x will be equal to 0. So substituting the value of x as 0 in the above equation, I'll obtain the value of y, which will become the y-intercept, or the point at which the line will intersect y-axis. Okay, so its value will be minus c upon b. All right. So now these are the 2 points that we have obtained. So you can mark these 2 points on the graph on the xy plane, and you can join a line which is passing through both these points. All right. Okay. So now let's have a look at some of the examples for this. Right. So I have the equation 4x plus 3y equals 12. Okay. So let us obtain these 2 points. Now putting x as 0, the value of y will be equal to minus 12 upon 3, and that is minus 4. Okay, so this point is 0 comma minus 4. Okay, so 0 comma minus 4 will lie on y axis, and minus 1, minus 2, minus 3, minus 4. So this will be the point 0 comma minus 4. All right. Now to obtain the second point, I'll put y as 0. All right. So substituting y as 0, the value of x will be equal to minus 12 upon 4, and that is equal to minus 3. So the point here will be minus 3 comma 0. Okay, and this point will lie on x axis on the left hand side of the origin. So this will be the point, the another point from which the line will be passing. All right. Now I can draw a straight line which is passing through these 2 points. So let's say this is the straight line which is passing through these 2 points, and this is the graph of the linear equation which we are talking about, 4x plus 3y plus 12 equal to 0. Okay, so this is the straight line for this particular equation. Now talking about a few specific cases in linear equations. So if you have any equation like this, x equal to 4. So x equal to 4, I'll mark this point. Okay, and this particular line will be parallel to y axis. All right. So any equation of the form x is equal to k is a constant, will be parallel to y axis. So it will pass through x equal to 4 and drawing parallel to y axis. So this will be the graph of this equation. All right. So a line which is passing through x equal to 4 and which is parallel to y axis will be the equation, or will be the general equation of x equal to k. Okay. Hi Vaishnavi, good evening. Okay, so moving ahead, taking another specific case, y equal to minus 3. Now y equal to minus 3 will be a line which is passing through y equal to minus 3 here, and will be parallel to x axis. Okay, so this will be the graph of an equation like this, which will be parallel to x axis. All right, so I can generalize this equation y equal to k. So equation of y equal to k will be a line which is passing through the point y equal to k and will be parallel to horizontal axis or parallel to x axis. All right. Okay. Now next case is the equation of a line which is passing through origin. So in this case, the constant c will be missing. So if you look at the general equation ax plus by plus c equal to 0. So in any equation in which constant c is missing, okay, I can say that that equation, the graph of that equation will pass through the origin. All right. So in this case, what you can do is you can obtain 2 other points. So one being origin. So if I'll put x as 0, the value of y will also be equal to 0. Now you can obtain any other point. You can substitute y as 1, y as 2, or any other number, and you will get the value of x. So in this case, the value of y is 1, the value of x will be minus 3. All right. So the point origin, This is the first point. And the second point is minus 3 comma 1. So minus 3 comma 1 will be a point somewhere here. Okay. So now you can draw a straight line which is passing through these points. So drawing a straight line which is passing through this point. So this will be the graph of the given equation. All right. So this will be the final graph of the given linear equation. Fine. So this was about linear equations. So you don't have to go into very depth when it comes to linear equations. All right. So let's quickly start with quadratic expressions. Now, quadratic expressions will be something that will be very important as far as graphs are concerned. So we have seen the general form of a quadratic expression. So fx, let's say this is a polynomial function of the form ax square plus bx plus c. This is basically a general form of a quadratic expression. All right. Now here a has to be not equal to 0. A cannot be equal to 0. So if a is equal to 0, this expression will not remain a quadratic one. Okay. So a cannot be equal to 0 in this case. Now if I talk about the graph of a quadratic function, it will always be a parabolic curve. Okay. So any expression which is a quadratic in x, as in ax square plus bx plus c, the graph of this quadratic function will be a parabola, and the axis of symmetry will be parallel to the y-axis. Now what do we mean by axis of symmetry? Now in the previous session, we have seen the graph of even functions. So we can say that if I'll plot the graph of any even function, that graph will be symmetric about vertical axis. That means that graph will be symmetrical about y-axis. So even function का जो भी graph होता था, it was symmetric about y-axis. For example, if I'll plot a graph like this, okay, so I can say that on the left hand side and the right hand side of y-axis, the graph is exactly same. So this graph is symmetrical about y-axis. Okay. Now if I'm talking about the graph of any quadratic function which is a quadratic in x, like ax square plus bx plus c, okay. Now the graph of this function will be symmetrical about any axis which is parallel to y-axis. So I can say that if, let's say this is positive x-axis, this is negative x, positive y and negative y. Okay, so the graph of quadratic function will always be a parabolic curve, definitely, and its axis of symmetry will be parallel to y-axis. So consider any line which is parallel to y-axis. Let's say this is the line. Okay, so the graph of a quadratic function can be something like this, a parabola which is symmetrical about the dotted blue line that I have made. Okay, so dotted blue line is the axis of symmetry of the parabolic curve that I have made. Okay, so I can say that axis of symmetry of this parabola is also parallel to y-axis. So this axis of symmetry can lie anywhere. Okay, this axis of symmetry can lie anywhere. So graph can be something like this as well. Okay, symmetric about the vertical dotted blue line that I have just made. All right, fine. Now we'll get into details of quadratic functions, don't worry. Okay, so basically important thing to understand is the graph of a quadratic function will be a parabola. Okay, now it can be an upward opening parabola or it can be a downward opening parabola. Okay, now let's have a look at when will you have an upward opening parabola and when will you have a downward opening parabola. Okay, so let's get into details of quadratic expressions, plotting the graphs of expressions like this. Okay, now I'll take the first case. The expression is ax square plus bx plus c. Okay, and we want to plot the graph when a is positive. Okay, now whenever a is positive, then you may have three types of parabolas possible. Okay, three different cases will be there. Now in all the three cases, the graph will be an upward opening parabola. Okay, so when a is positive, the graph will be upward opening. Okay, it has to be a parabola, yes, definitely, but it will be an upward opening parabola. All right. Okay. Satyam, once again, please. So Satyam, I think you have joined a little late. ठीक है? So एक बार दोबारा से देखना पिछला जो भी मैंने कराया है. Okay, I'll just quickly repeat about quadratic expressions that for a quadratic expression, the graph will always be a parabolic curve. ठीक है? So it will be a parabolic curve and either it will be an upward opening parabola or a downward opening parabola. These are the two possibilities. Okay? Forget about the axis of symmetry right now. You will understand it in a few minutes. Okay? So the first case is when A is positive. So when A is positive, we will have an upward opening parabola. Okay? Now this particular case is subdivided in three different possibilities. Okay. Now the graph can be, obviously we know that it is an upward opening parabola. So the graph can be of three types. Number one, it is completely above x-axis. That means it is not touching or not intersecting x-axis. Okay, fine. So completely above x-axis. Second case can be, it may be touching x-axis like this. All right. And the third case can be, it may be intersecting x-axis at 2 points. So these are three different cases. Okay. Now guys, if you understand quadratic equations, in quadratic equations, depending upon the value of discriminant, we decide the nature of the roots of quadratic equation. Okay, so the three cases are if the discriminant, so let me write what discriminant is. Okay, so I'll erase everything from here. So one thing I know that this will be an upward opening parabola. All right. Now discriminant in a quadratic expression is b square minus 4ac. Okay. Now we used to have three different cases. Case number one, if discriminant is less than 0. Case number two, if discriminant is equal to 0. Case number three, if discriminant is greater than 0. Okay. Now depending upon the value of discriminant, we will decide the location of this upward opening parabola. So case number one, if discriminant is negative, discriminant is less than 0, then we can say that the roots are not real. The roots are imaginary. All right. Second case was when discriminant is equal to 0, then the roots are equal. And the third case, when discriminant is greater than 0, the roots are real and distinct. Okay, so there will be two different roots whenever d is greater than 0. Okay, now if discriminant is greater than 0, that means case number 3, I have two distinct roots. That means the graph will intersect x-axis at two distinct points. Okay, so general form of this parabola will be something like this. General shape of the parabola will be something like this. It will still be an upward opening parabola with intersecting x-axis at two distinct points. Okay, now the points at which this graph will intersect x-axis will become the roots of this quadratic expression. All right, so this was one of the cases when discriminant is greater than 0, then the graph will intersect x-axis at two distinct points because we have two distinct real roots. Okay, now case number 2, when discriminant is equal to 0, then the roots are equal, or effectively we have only one root. So the graph will pass or touch x-axis exactly at one point. Okay, so the general form of the graph, general shape of the graph will be something like this when it is touching x-axis at a single point. Okay, now in the last case, when discriminant is less than 0, then the expression will not have any real roots. So that means it will not intersect, not touch x-axis at any point. Okay? So it will neither intersect nor touch x-axis. So the graph will be completely above x-axis like this. Okay? Fine. So the first case, when A is positive, the graph will be an upward opening parabola. Upward opening parabola can be of three types: completely above x-axis if discriminant is less than 0, touching x-axis if discriminant is equal to 0, and intersecting x-axis at 2 points if discriminant is greater than 0. Okay, fine. So these are three cases. All right. Wait, Vaishnavi, we are coming to downward opening parabola. Okay, fine. Hi, Krupa. Good evening. So, Vaishnavi, we will discuss the case when it will be a downward opening parabola after this. So, let's move ahead and look at the next case. When the value of A is negative, that means coefficient of x square has a negative sign. So, in this case, the graph will be a downward opening parabola. Okay. Now again, downward opening parabola can be of three types, right? So downward opening parabola, it will be completely below x-axis, touching x-axis, and then intersecting x-axis at 2 points. So case number one, again, it will depend on the value of discriminant. Yes, Vicky, not in this session, but okay, so Vicky, I'll be teaching inequalities wali lines also. Basically, inequalities means when the graph will cover certain portion, okay, certain area. But I'll be teaching those things only after I'm done with the basics. So the next three sessions will be very important for you. So understand the basics and then we'll gradually increase the level of difficulty. All right. Okay. So when discriminant is less than 0, now, when discriminant is less than 0, the graph will be completely below x-axis. So it will be a downward opening parabola, something like this. It will neither touch nor intersect x-axis because the roots will be imaginary. All right. Now, second case, when discriminant is equal to 0, both the roots are equal. Okay, roots are equal. Effectively, we have only one root and the graph will touch x-axis. The third case, when discriminant is greater than 0, then we will have two distinct roots and they both will be real. So the graph will intersect x-axis at two different points, and these two different points will be the roots of this quadratic expression. All right, fine. Now let's look at some of the specific cases of quadratic expressions. Okay, so quadratic function, a very general quadratic function we have discussed in the last session as well. Y equal to x square. Now y equal to x square is very simple to plot. It will pass through origin. Okay, will be symmetrical about y axis. Okay, so at x equal to 1 and at x equal to -1, we will get same value of y. At x equal to +1 and at x equal to -1, the value of y will be +1 in both the cases. Similarly, at x equal to +2 and -2, the value of y will be +4. So this will be the value of y. Similarly, for +3 and -3, the value will be +9 in both the cases. And the approximate, the rough shape of the graph will be something like this. Okay, just pardon my drawing. So this will be the rough shape of this graph. All right, so this is y equal to x square. Okay, now we know that this is the graph of y equal to x square. Now if we want to plot the graph of y equal to x square upon 3, okay, x square upon 3, I can say that for the same value of x, for the same values of x, the values of y will decrease. Okay, so whatever graph we have made earlier, here for y equal to x square, इसका जो slope है वो थोड़ा सा कम हो जाएगा. Fine. So right now the slope is something like this. It will reduce. So graph थोड़ा सा open up हो जाएगा and the graph will be something like this. All right. For the same values of x, the value of y has decreased. सो ग्राफ का स्लोप थोड़ा थोड़ा कम हो जाएगा. सो एक्स स्क्वेयर अपॉन 3, एक्स स्क्वेयर अपॉन 4, एक्स स्क्वेयर अपॉन 5, द ग्राफ slope will keep on reducing. Okay. On the other hand, if you are plotting the graph of y equal to 2x square or 3x square or 4x square, the slope of this graph will keep on increasing. So graph will be something like this. थोड़ा सा ज़्यादा steep हो जाएगा curve, okay, and it will keep on getting steeper and steeper as you will increase this coefficient in front of x square. Okay, so very few general things that we are discussing here. Okay, fine. Now let's move on to and look at the graph of a function like this. So this is a quadratic expression but in the factorized form. So friends, if a quadratic expression is given in non-factorized form, so if यहाँ पे तो factorized form में given है, अगर factorized form में given नहीं है, then also we can plot the graph, but not right now. Okay, we need to learn some other basics which I'm going to tell you in a few moments when it comes to shifting of graphs. So first of all, we need to understand shifting of graphs, then we can plot the graph of any general function. Okay, so you have to wait for that. So in this case, we have already discussed in the previous sessions as well. So here I have x minus 3 into x plus 2. So the roots of this expression are plus 3 minus 2. Okay, so I can say that the graph will pass through x equal to plus 3 and x equal to minus 2. Okay, so these are the 2 points. So it will be a parabola passing through these 2 points. Now the question is, will it be an upward opening or will it be a downward opening parabola? So upward opening, downward opening किस चीज पे depend करता है? It depends on the value of a. Okay, so if you will open up this expression, अगर इनको multiply करोगे, so you will get x square. Okay, and the coefficient of x square will be 1. And hence it will be a positive number. Okay, so expanding this, you will get to understand that the coefficient of x square will be a positive number. Okay, and hence the graph will be an upward opening parabola. Okay, no Gaurav, you cannot plot the graphs of all the types of equations putting random values. No, it is not possible, because there are some functions whose graph is something like this as well. Okay, so you cannot put any random values. So इस टाइप के ग्राफ को प्लॉट करने के लिए आपको बहुत सारी वैल्यूज पुट करनी पड़ेंगी. Okay, so it's better to understand the general shape of some different types of expressions. Okay, so in this case, the roots are plus 3 and minus 2. So the graph will pass through plus 3 and minus 2 and it will be an upward opening parabola. So the general shape of this graph will be something like this. All right. So this will be the shape of this graph. Now moving on to the next expression, 3 minus x into x plus 2. Okay. So what I'll do is I'll take minus common from here. So minus bracket x minus 3 into x plus 2. So again in this case the roots are 3 and minus 2. So the graph will pass through plus 3 and minus 2. But in this case the value of a is minus 1 and hence it's a negative number. So this particular graph will be a downward opening parabola. Alright, so the general shape of this graph will something be like this. It will be a downward opening parabola passing through x equal to minus 2 and x equal to plus 3. Alright, fine. Okay, now let's move ahead and shift our focus to the shifting of graphs. Some basics which are related to shifting of graphs. And my dear friends, this particular concept is very important, and I'll be using this concept in the next 2 sessions, using which you will be able to plot the graph of a lot of functions. Okay, so let us understand this particular concept carefully. Now shifting of graph में क्या होता है? Let's say you are given the graph of any function, be it a linear function, quadratic function, sine function, trigonometric function, log function, whatever is the function. You are already given the graph of that function. So given the graph of y equal to f of x, okay, now if you want to plot the graph of y equal to f of x plus k, okay, I'll give you an example, don't worry. So using the graph of y equal to f of x, which is already given, you want to plot the graph of y equal to f of x plus k, where k is any positive number. Okay, k can be 1, 2, 3, 4.5, 6.3. It can be any positive real number. All right. So what will happen is the graph of y equal to f of x, the original graph, will shift upwards by k units to obtain, to give you the graph of y equal to f of x plus k. All right. Let's take an example. So I'll take an example of the graph which you have already seen, y equal to x square. Okay. So we have already seen that the graph of y equal to x square will be something like this, right? It will be an upward opening parabola passing through origin. Now, if you want to plot the graph of y equal to x square plus 3, y equal to x square plus 3, okay, the value of k here is 3. So this graph, the original red color graph, will shift completely by 3 units upwards. Okay, so original graph जो है वो 3 units upward shift हो जाएगा. So इसका ये जो point है, this was 0,0 origin. So now this point will shift to this point, and the new graph will be something like this. Okay, so the original graph, the red wala graph, will shift upwards by 3 units. Okay, so जो मैंने blue graph बनाया है, this is the graph of y equal to x square plus 3. Yes, Vicky, it will shift upwards by 3 units. All right. Okay, now let's go ahead and look at the next part. So again, if you are given the graph of y equal to f of x, and you want to plot the graph of y equal to f of x minus k, where a k is again a positive number. So earlier it was plus k, now it is minus k. So in this case, the graph will shift downwards by k units. Okay. So again, if you are given the graph of y equal to x square, which can be drawn something like this. Okay. So if you want to obtain the graph of y equal to x square minus 2, so the graph will shift downwards by 2 units. Okay, so this will be the point. So earlier it was 0, 0, now it is 0, minus 2. Okay, so 0, minus 2, and this graph will be parallel to the original graph, but it will shift downwards, completely downwards by 2 units. All right, so this will be the new graph. Yes, exactly, Siddharth. The width, everything will be same. So graph as it is उठ के नीचे की तरफ shift हो जाएगा by 2 units, or it will shift upwards by 3 units. Okay, fine, Siddharth. So rest, each and everything will remain same. It's just the entire graph's shifting that will happen. Okay, fine. So we have just seen two things. Number one, y equal to fx was given. I want to plot the graph of fx plus k. So the graph will shift upwards by k units. For fx minus k, the graph will shift downwards. Okay. Now carefully understand the next two things that I'll be telling you. Given the graph of y equal to f of x, we want to plot the graph of y equal to f of x plus k. Okay, don't confuse it with f of x plus k. There is a difference. Okay, I'll give you an example. Now in this case, the graph will shift leftwards by k units. यहाँ पे प्लस है, हमें ऐसा लगता है कि राइट की तरफ शिफ्ट होना चाहिए. No, the graph will shift towards left by k units. All right, am I clear? So if you are given the graph of y equal to x square, which is something like this, okay, and you want to plot the graph of y equal to x plus 4 whole square. Okay, the value of k is 4. So this graph will shift leftwards by 4 units. So right now this is origin 0, 0 se pass kar raha hai 1, 2, 3, 4. So this point will come at this place. Okay, so that is -4, 0. Okay, and this graph will entirely shift towards left by 4 units, and wait, the new graph will be like this. Okay, the new graph will be in blue color. Here I'm plotting the graph of y equal to f of x plus k. Okay, f of x plus k. All right, so here the graph will shift towards left by k units. On the opposite, if you want to plot the graph of y equal to f of x minus k, then the graph will shift rightwards by k units. Okay, so again giving you an example. So if you have y equal to x square, this graph given to you, something like this, and you want to plot the graph of y equal to x minus 5 whole square. All right, so the graph will shift 5 units towards right. So 1, 2, 3, 4, 5, and this point will be 5, 0. Okay, and the new graph will be something like this. All right, so this is all about shifting of graphs. Now friends, this is very important from the point of view of plotting any other type of graph that you will be looking in the next few classes. Okay, so in tomorrow's session at 6 o'clock, I'll start with taking on quadratic expressions in their general form, not in the factorized form. So let's say you want to plot the graph of x square plus 5x minus 3 like this. So the expression will not be given in the factorized form. Okay, so we'll be looking at graphs of such functions, and then we'll be looking at some of the basics which is based on reflection of graph. Okay, so reflection of graph, that means we'll be studying modulus function, how to plot the graphs of modulus functions in tomorrow's session. Okay, so till then please revise whatever we have done in the last few minutes. So shifting of graphs, y equal to f of x plus k, graph will shift upwards. F of x minus k, the graph will shift downwards. So just understand the difference between the expressions that I have explained to you. Okay, next is f of x plus k, the graph will shift leftwards, and f of x minus k, the graph will shift rightwards. So these are 4 very important cases that will be used everywhere when it comes to plotting of graphs. All right. Now, Vicky, you're asking, is it correct to check the plotting? Vicky, if in case your basics about shifting and reflections are clear, there is no need to check by substituting different points after plotting a graph of any function. Okay, so it is not required. Key 1, x equal to 1, y equal to 16, x equal to 2, y equal to 9. There is no need to check for that in case you have basics in place. Okay, because it will take a lot of time in checking, in putting these points and checking the graph. All right, okay, so friends, that's all from my side for the day. In case you like the session, please do press the like button. Okay, please do comment in the comment section, share this session with your friends, and subscribe our channel. Now this is the schedule that we run throughout the week on the YouTube channel of BYJU'S Exam Prep. Friends, right now there is a big discount that is going on the online programs, online classroom programs. So we have flat 25% off. You can use the promo code that is given at the bottom of the screen. For any other information, you can call at this number that is also given at the bottom. Now, in case you are aspiring for CAT 2021, we have just started with a 2-month crash course. Okay, and basically in this you will get each and everything, starting from live classes, some practice questions, chapter wise notes, as well as mock papers. All right, so This is the set of faculty who will be taking this batch. So I'll be one of the faculty members who will be teaching quant in this particular batch. You can join, you can just take some trial sessions in this batch. Okay, so you can just download BYJU'S exam prep app and you can have an access through all these sessions. Now another batch for CAT 2022, a complete course, batch number 5. So students who are preparing for CAT 22, this batch is apt for all of you. Plenty of live sessions, practice questions, as well as notes will be available to all of you. Now, people who are preparing for CAT 21, you cannot afford to miss All India Open Mock CAT starting from 28th of September. So it has already started and it will go for the next 7 days. So please do register for this open mock for CAT 21. Now these are different CAT courses and other MBA examination courses that we offer here at BYJU'S Exam Prep. Some online classroom programs for CAT 21 and a complete course for CAT 2022 with all their complete details are mentioned. The list of experts that we have on our panel. Please do follow us on Instagram, Facebook, join us on Telegram. Do subscribe our channel. Thank you very much and we'll see all of you tomorrow. Bye bye.